Alumina is a chemical compound comprising of aluminium and oxygen. There are four main alumina products that are manufactured and are classified based on their purity. When the grade is greater than 99.9% purity, it is known as high purity alumina or HPA. This analysis takes a closer look at 4N HPA and its uses, supply and demand factors, as well as how it is produced. 4N HPA is the critical ingredient in the production of synthetic sapphire, and there are no other materials that can be substituted for HPA in its manufacture. Sapphire is second only to diamonds when it comes to hardness. This attribute, combined with its scratch resistance, has seen sapphire glass traditionally used in high-end watch faces and camera lenses. The major current consumer of HPA is the LED industry. This is due to synthetic sapphire wafers' ability to withstand high temperatures generated from the component chemicals and electronics which produce light. They also transmit light more readily without absorbing energy as heat. And whilst LEDs will remain the cornerstone for the HPA industry in the future, there is expected to be significant growth in demand from the lithium-ion battery and smartphone industries due to alumina also being a fire retardant, as HPA can coat the ceramic separator sheets that divide the cathode and anode electrodes used in batteries. This would have eliminated the recent and widely publicized issue of smartphone batteries overheating and catching fire. Global demand for HPA in 2016 was around 25,000 tonnes per annum. But with industries that rely on HPA expected to boom over the next decade, demand is also set to increase, with forecasts of around 87,000 tonnes per annum by the year 2024. The three main drivers for this growth are the global adoption of LEDs as a cost-effective and energy-efficient replacement of traditional lights, advancements in lithium-ion battery technology, and the use of HPA in the coating of battery separators, as well as the growing use of sapphire glass by smartphone manufacturers. 8 high-profile companies currently supply around 50% of global demand for HPA, with the largest producer being Japanese multinational Sumitomo. As current HPA production, which is dominated by chemical companies or multinationals, is produced through a highly expensive, multi-stage processing methodology. However, ASX-listed Altech Chemicals has developed a process which both simplifies and reduces the cost to create HPA.
So the Altech technology uses hydrochloric acid to extract alumina from kaolin. As you know, kaolin is a very white material. It's used as a whitening agent for paper and ceramic ware. And the technology allows us to produce 99.99% alumina product at nearly half the cost of the current technology. We have 3 stages of purification in our process. The technology has been around since the 1980s, and it allows us to produce a very pure alumina product that's used in the sapphire and lithium battery industry.
Welcome to the world of sapphires. Valuable, unmatched beauty, rarity and purity are the ultimate qualities of this precious gemstone. Virtually unscratchable, sapphires are the only natural material on Earth as hard as diamonds. In nature, sapphires are formed from high purity alumina deep in the Earth's crust. Like any naturally occurring gemstone, heat, energy and pressure over millions of years stimulates the growth of these natural sapphire crystals. Today, mankind has the technology to recreate the formation of sapphires using high purity alumina under intense pressure and heat. The formation takes place in high-tech furnaces where large single sapphire crystals are grown from high-quality alumina. From these crystals, sapphire wafers and sapphire glass are extracted using diamond cutting technology. These synthetic sapphires, like the natural sapphire gemstones, are highly valuable and prized. Today, synthetic sapphire is playing a large and growing part in our everyday modern lives. Sapphire wafers are used in the manufacture of cost-effective, energy-efficient LED lights. LEDs, the lighting of the future, offer huge energy savings and are rapidly replacing traditional light globes around the world today. Semiconductors in our electronic devices, phosphor-plasma televisions and scratch-proof watches are some of the many applications that belong to the sapphire family. Smartphone manufacturers are already making the exciting transition to the unscratchable sapphire display screens. We all look forward to a sapphire future of unscratchable glass. To meet this sapphire future, Altech Chemicals, an Australian company, is aiming to be the world's leading supplier of high-purity alumina. Altech has rapidly grown to consolidate its strategic advantage through the rapid development of its kaolin mine in Western Australia and its proposed high-purity alumina chemical facility in Johor, Malaysia. The company's proposed state-of-the-art production facility will produce high-purity alumina, specifically designed for the synthetic sapphire market. Well positioned in the Asia-Pacific region, customers around the world will trust the quality and reliability of Altech's high-purity alumina products. Altech's proposed expert customer support and state-of-the-art packaging and distribution service will be second to none. Altech Chemicals is aiming to be the leading supplier of the key ingredient for sapphire glass, high-quality pure alumina. Altech Chemicals, meeting a sapphire future.
Okay, good afternoon, ladies and gentlemen. It's a pleasure to be here and be able to provide you with an update on Altech Chemicals and our high-purity alumina project. So Altech's a Perth-based company. We're listed on the ASX, our code ATC, and we're also now listed on the Frankfurt Exchange, dual listed, A3Y, and we're positioned to become a world-leading producer of high-purity alumina. So just a bit of background on high-purity alumina. As the name suggests, it's purified alumina at 99.99% purity, and importantly, negligible sodium, iron and other impurities in the product. And it differs from smelter-grade alumina, which is about 99.95% alumina and has sodium impurities in it. The demand for HPA, primarily it's the synthetic sapphire industry, as you saw in the videos, and that's underpinned really by the LED industry. Synthetic sapphire makers demand very pure alumina and importantly, alumina without any sodium in it. The lithium-ion battery sector is in the mining vernacular, the blue sky demand for high-purity alumina, as we're seeing these manufacturers demand high-purity alumina with minimal impurities for use in lithium-ion batteries, and we'll talk a bit more about that in the coming slides. Like a lot of industrial minerals or chemicals, you pay a price for purity. The price of HPA now in Japan is around $30,000 a tonne or $30 a kilo. When we put our feasibility study together, we used a rather more conservative price of $23,000 a tonne. Now this slide here seeks to illustrate the synthetic sapphire business and how high purity alumina plays a part, or the key part in that process. So to produce synthetic sapphire, you start out with high purity alumina. It's heated up and cooled down over a period of about 21 days in kilns, and from that comes a large single synthetic sapphire bull, pure sapphire. Cores are cut from the bull, and then there's really two main streams. There's the wafer stream, and the wafers underpin LED substrates and also computer chips or microprocessors. Then there's the shapes, and synthetic sapphire is extremely hard. It's 9 on the Mohs scale, just behind diamonds, and this is why it's demanded for things such as camera lenses, watch faces, and more for the covers of iPhones. And the next video just illustrates the properties of synthetic sapphire and why it's being more highly demanded. This is an Apple Watch. I think we've lost the sound, have we? Yeah. So that's quite impressive, and if you do own an Apple Watch, you can do that at home if you like. Just don't use a diamond-tipped drill bit, please, it might scratch it. Look, what we're seeing is the uptake of synthetic sapphire glass in iPhones, we saw HTC release the Ultra 128 megabyte phone earlier this year, and that has a synthetic sapphire screen. And Apple has used synthetic sapphire in their iPhones for years in the camera lens and also in the fingerprint recognition screen. Both of those, it's important that they don't scratch. Also, Huawei and Vertu, which are luxury phone manufacturers, use synthetic sapphire in their screens as well. Oops, next slide. But it's really the light-emitting diodes, as I said before, and you can see on the right-hand side a cross-section of a LED light, and it's underpinned by a synthetic sapphire substrate. And to the bottom is what the demand curve looks like for LED lights, and we heard from the previous speaker about the electrification of Africa, but this phenomenon's happening all around the world. And not only are people using LED lights, but they're also replacing their incandescent bulbs with LEDs. And this is really what underpins the demand for high-purity alumina. Lithium-ion batteries, it's the separator sheets. These are the sheets that separate the anode and the cathode. And manufacturers are using high-purity alumina to coat these sheets as a retardant and also as a fail-safe in these separators. This is what the demand looks like for battery separators. We've all heard about the uptake of lithium-ion batteries and the electrification of the world. This information's from a study done by Deutsche Bank last year. We can see at the moment the use of high-purity alumina in 2017 is quite small, less than 1,000 tonnes, but growing extremely rapidly in sync with the lithium-ion battery industry. Global high-purity demand overall, an American firm, Grandview Research, put out a number earlier this year. They predict that the high-purity alumina market will be worth $6.4 billion by 2024. This is a bit more aggressive than the forecast that we're using, but the market at the moment sits around 20,000, 25,000 tonnes, but growing rapidly, 17-18% a year to well over 80,000 tonnes in 2024. Our plant should be on stream by 2020, so you can see it'll be placing product into a market where there's really strong demand growth. Now, the demand for high-purity alumina, no surprise, it's all in the Asia-Pacific region, the manufacturing hub of the world. Our plant in Malaysia, in Johor, just across the road from Singapore, is really ideally situated to service the demand of the manufacturers for our product. Taiwan, China, South Korea, the usual manufacturing hubs in Asia. High-purity alumina has been around for a long time. The current producers are listed on that slide. It's quite interesting, it's very fragmented. There's no dominant single producer, and most of the existing producers are simply little divisions within large conglomerates, and some of the names you'll recognise up there, such as Sumitomo or Sasol. The way that these producers manufacture high-purity alumina at the moment is actually by aluminium metal, and those of us that understand the aluminium industry know that 40 to 60% of aluminium metal's cost is made up of electricity. So they're using a very expensive feedstock, and it's sort of like a three-step process. Aluminium comes from bauxite, smelter-grade alumina, aluminium metal. They reprocess it, drop out the sodium to produce high-purity alumina. Our process is a single-step process using a high alumina feedstock in kaolin, and using an established HCl process. In one step, we take the high-purity alumina out of the kaolin. This deposit is just down the road from Perth, about 140k to the east, close to the highway. Mining lease has been granted, and the project, as of today, we put out an ASX announcement this morning, but it's fully permitted. The mining is approved, the construction of the plant's approved. So basically, subject to our financing, which I'll talk about in a minute, it's ready to go to start exporting the product from the Port of Fremantle up to Johor in Malaysia. This is just a quick analysis of our deposit on the right-hand side. We've got a huge resource there. We've got more than 250 years of kaolin. We've done a reserve on 30 years, which is the feasibility study for the project life. But you can see nature has done just an amazing job for us. The project, or the deposit, simply consists of alumina and silica with very low impurities, remarkably very low iron, and even more remarkably in WA, just basically no sodium in the deposit. So it's very clean. Just a little bit about our process. We're using an established process. We didn't invent it, unfortunately. It's open technology. It was developed in the 1980s in the US alumina industry. The US doesn't have a lot of bauxite, but they've got a lot of kaolin. They ran a program to produce alumina from kaolin. It's very successful, but on a cost basis, it couldn't compete with the Bayer process, which introduces sodium into the product. And there was little demand for high purity alumina in the 1980s. But now, compared to the way traditional producers are producing high purity alumina, this process is a lower cost, and the demand for high purity alumina has arrived. LEDs, sapphire glass, lithium-ion batteries. So we're tapping into that demand today. This is where we'll sit on the cost curve. We'll be a lower cost producer and at about the same impurity. The reason we can do that is we own our own feedstock. Malaysia is a relatively low cost country, and we're reusing hydrogen chloride in the process. We have a beautiful German HCl recycling plant which we use. So the project status, so we announced our BFS in 2018. Mitsubishi Corporation, they'll take all of our products, so we signed them up for a 10-year offtake agreement, and there's the option to extend that, but they'll take all of it. The plant site in Malaysia in an established industrial park is secured. As I just said, the Meckering project's ready to go. We've been working with the German government. This is a very high-tech plant. Most of the plant and equipment comes from German or other European Union countries, and Germany has a wonderful export credit facility which we're going to tap into, and we've been working with German government-owned bank KfW. So the bank's just finalising its due diligence. They'll be the sole lender for the project. We lost about 2 or 3 months with changing out EPC contractor, but we've now settled with SMS Group, a German contractor that's experienced with the high purity alumina business. We've agreed on a fixed price turnkey lump sum EPC contract. At the moment, they're pricing up the EPC contract in Germany, and they should be done before the end of this year. They're offering us throughput and process guarantees, which are most important for project finance, as you'd understand. The road ahead, it's amazing that it's the end of August already, so we've only got 4 months left, but we want to wind up the EPC contract price in the next couple of months. The bank due diligence will be concluded, and then we'll make application for export credit finance from the German government before the end of this year. 2018 will be, once we get the debt approved, we'll be raising the project equity, and then we'll start construction in 2018 of the plant. The construction is 18 months to a 2-year process, and then commissioning. Our plant's fully designed, and as I said before, the EPC contractor's costing it up now. That's what it looks like. It's on a 4-hectare site up in Johor. There's, as in any established industrial park, there's power, water, gas, all that we can tap into. So the infrastructure's fabulous up there. Just a final graph, just the market's finally catching up, I think, to our project and the company, and that's just a bit of a diagram of what's happened to the market capitalisation in the last 18 months. I've got great shareholders. We've grown the shareholder base from 640 to 1,700 shareholders, and we ran an SPP a few months back, and it was fantastically supported by our shareholders. So we really do believe we're in the right place, the right time, the right feedstock and the right technology. Not many people have heard about high purity alumina, but we think we'll take a great advantage of the growing demand for the product. And there's our disclaimer. So thank you very much, ladies and gentlemen.